Good evening, everyone, and welcome to week 5. For the first question, why is this data analysis the most appropriate for my study? My study is looking at the effects of a structured 12-week strength training program on adolescent throwers, athletes in the shot put events, discus events, and weight throw events. Because of the developmental variability in adolescence and the fact that this is a performance-based intervention, I needed a design that could clearly separate training effects from the normal growth occurring in these adolescent groups. That's why I chose a randomized control design with a 2x3 mixed factorial ANOVA method. It allows me to compare two groups, those in the strength training program versus those in regular training, across 3 time points: pre-intervention, mid-intervention, post-intervention. This is the best fit just because it doesn't show whether a group differs, but also how their performances change over time with any sort of intervention. The outcome variables, such as throwing distance, vertical jump, 1 rep max, squat, and bench, and grip strength, are all continuous data, which also align well with the ANOVA assumptions. I also added Pearson correlations because I wanted to see how improvements in strength and power metrics actually connect to throwing performance itself. So overall, the statistical plan is tightly aligned with both the data type and the research question itself, which is being how does a structuredized 12-week program influence strength and explosive power in adolescent athletes and throwing events. For question 2, how will I ensure that the data is valid and reliable? Reliability and validity come down to both the tools and the protocols in place here in this study. For measurement, I'm using validated and widely used instruments, a Vertec jump mat or force plate for vertical jump, an NSCA standardized 1 rep max testing for strength, and official throwing implements that have all been weighed and checked by New York State in the section as well. So 8-pound implement for women for shot put, 1 kilo for discus, and then 1.2 for boys, 12 pounds for shot put, and then the weight throw is universal at the high school level, so it's 25 pounds for both. And then by using these official implements, each of these helps to show and provide reliable measures across repeated trials. I'll also take multiple trials and use the best score, which is common practice in performance-based testing, to reduce variability. In terms of validity, the testing protocols mirror the actual performance environment. Athletes will throw with competition standard implements, and lifts will be supervised and spotted to ensure form. To protect internal validity, training will be supervised by certified strength and conditioning specialists to ensure fidelity to the program. Finally, I'm accounting for maturity differences since I have a pretty big age gap since it's high school. You might have a 13-year-old, 14-year-old, because some of our RC athletes are actually middle school age adolescents all the way to 18 years old. And because of this, they're going to adapt differently to training programs that are given. And by estimating peak height velocity and including its covariate, if needed, we can reduce the confounding effect of growth, maturation, performance on the actual performance outcomes as well. And then for the final question, what alternative methods could be used and why did I choose this method specifically? There are a couple of other approaches that I could have taken with this study. One alternative would have been an ANCOVA method of measurement, controlling for maturity, offset, and baseline strength as covariates. This could help isolate the training effects even more. Another option would be repeated measures of MANOVA, which would analyze all dependent variables together and account for their relationships. I did consider these, but I chose to do a mixed factorial ANOVA because it's straightforward, it's interpretable, and it matches the practical scope of the study, which is what we're aiming for, because the study is essentially to help out all coaches within this group specifically and find the most efficient way to train these young athletes. With a relatively small sample size that I have of about 20 athletes, more complex methods like MANOVA will end up diluting statistical power further on with that. The factorial ANOVA keeps the analysis robust while still allowing me to test the main question: does strength training produce greater improvements in performance compared to traditional training itself? So in closing, overall, The analysis plan is appropriate because it's directly matched to my variables and the design that I've taken with this approach. I've taken clear steps to ensure reliability and validity. While other methods could work, the chosen approach balances rigor with feasibility of the study, and the case study group and participants involved all take into account how we're doing the statistics for this. Thank you, and I hope everyone has a good week 5.